test Friday, the 5th. Okay, so it's our log test, 4-1. Okay, so it says to convert. Convert just means to change the form from logarithmic to exponential or exponential to logarithmic. Okay, so these are logarithmic to exponential. I'm going to turn all this, make it easier. Okay, so we take our base stays the same, and the others switch. So instead of having the m right next to the b, I'm going to have the x. Remember, it's b to the x power equals m. Now, remember, it's always to the power because we're changing it to exponential, which means it has to have an exponent, okay? Again, base, these switch, so to the y power equals 5. Okay, now if I'm converting from exponential to logarithmic, my base stays the same, so log base b, okay, and then they switch again, so y equals x. Now I want you to realize this is not b to the y power, it's just log baby base b, y equals x. So now this one's written backwards, which is totally fine, okay, log, my base is still b, whatever has the exponent, t equals a. If you need to rewrite it, b to the a equals t, rewrite it. Okay, so solve each logarithmic equation. So when it says solve, you're actually looking for an answer. Always look at the left side, or the side with the log, and see if you can type it in the calculator. This has no letters, which means I can type it in the calculator. Okay, so we're going to go here. Remember, you type math alpha math log base 3 243, enter, so x equals 5. Here, if you look, I cannot type it in the calculator right away. Okay, if I look on the left side or the side of the log, there's an x, so I can't type it in the calculator, which means I need to change the form like we did in 1 through 4. So base is x to the 5th power equals 1024. How do we get rid of the power of 5? We do a 5th root. Okay, so remember, you type whatever root you want, you hit math, and you go down to 5 where it has the x. So see how it made it a 5th root? 1024. So my answer is 4. Here, I cannot type it in the calculator right away, so I'm going to change the form. So base 25 to the 3 over 2 power equals x. 25 to the 3 over 2 power, so x equals 125. And we check the side with the log. I can type that in, so math alpha math log baby base 3 of 7. So it gives me this ugly number. I hit math, enter, enter. It doesn't give me a fraction, so I'm going to round. Okay, it doesn't tell me what to round to, so we'll just round to the 100th. So x equals 1.77. Okay. Now it says for number 9 through 14 to write each of the following as a single logarithm, which means right now it's 2, it's a double. Right now this is 3, right? This is 3, this is 3. We want only one word log and simplified, as simple as you can get it. Okay, so I want you to remember plus. Anytime you see plus, you're going to multiply. If you see minus, you're going to divide your arguments. Okay, so here I have a plus, so my arguments are going to be multiplied. So I'm still going to have log base b, 6 times 5. Use your calculator. Don't make simple mistakes. Okay, so this is going to be log base b of 30. There is my single log. There's only one log, and it's simplified. Now on number 10, I have 50 minus 2. We just said minus means divide. So I'm going to divide my argument. So log base b, 50 divide 2, gives me 25. Okay, now anytime you have one in front, you cancel it and make it your exponent to your argument. So this becomes log base b, 8 to the 2nd power is 64. Alright, Okay, now this one has multiple. It has a power, it has adding, and it has subtracting. So we need to make this, always get rid of the numbers in front first. Okay, so like this one and this one. Okay, it doesn't matter where it's at in the equation, but the number in front of a log, directly in front of a log. Okay, so 4 to the third power is 64. So this becomes log base 5 of 64 plus log base 5 of 2 minus log base 5 of 8. So plus means multiply, so 64 times 2. Minus means divide. Divided by 8 gives me 16. So my answer is log baby base 5 of 16. Okay. Here, get rid of the 4, the number directly in front of a log, and it becomes your power. Okay, so I get log base 7, log baby base 7 of 8 minus log base 7 of 4 plus log base 7. Well, what's 2 to the 4th power? 2 to the 4th power is 16. Now, divide, multiply. So 8 divide 4 times 16 is 32. So log base 7 of 32. Okay, number 14, last one in this section. What do we need to get rid of first? We need to get rid of this 2. Okay, this doesn't have a number in front, this doesn't have a number in front, so we're good. So 3 to the 2nd power, so it becomes log base m of 4 plus log base m of 9 minus log base m of 6. So 4 times 9 divide 6 gives us 6. So log base m of 6. Evaluate, solve, simplify, whatever you want to say here. It does say to round to the nearest hundredth place where necessary. So that means if you cannot turn it into a fraction. So first things first, this has a negative base, and that's not allowed. So this is not possible. Remember, you cannot have a negative base or a negative argument. This can't be negative, and this can't be negative. Okay, this follows those rules in our notes. I want you to remember that when these match and there's no exponent, it just equals 1. Now, could you type that in the calculator? Yes. Math alpha math, 5, 5. Guys, there's no reason anybody should get that one wrong. Now here, you can't type in the calculator, but they match and there is an exponent, so that's your answer. If you don't know, and there's a letter, it's the same letter, so it's the same number. So watch, you can plug whatever number you want in. So it's 3 to the 3rd power equals, I don't know why I picked 3. We could pick a different number. So like 5 to the 3rd power. It still equals 3. As long as those match, the exponent is your answer. Okay, here, 7 to the log base 7 of 4. Again, the bases match, so 4 is your answer. Again, type it in your calculator. 7 to the math alpha math, log base 7 of 4. It's 4. Nobody should get those wrong. It's done in the calculator. Even if you type this one in the calculator, it'll tell you error. Alright. Okay, so 19 and on. So it says solve the following equations, show all steps, round to the nearest hundredth when necessary. So that's when you cannot turn it into a decimal first. A fraction first, sorry. Okay, here, again, check your side. Can you type it in the calculator? No. So we're gonna change forms. So 81 is my base to the 3 over 2 power equals x. 81 to the 3 over 2 power is 729. So x equals 729. Okay, here we cannot type this in the calculator. So we're going to change the form. Log base 4, because the bases stay the same, and then these switch. So 1 over 7 equals x. So now we can type that in the calculator. Math alpha math, log base 4, the 1/7. Alpha y equals enter. So it gives me this. I'm going to do math enter enter. It doesn't turn it into a fraction. Therefore, this is one of the ones that's necessary to round to the thousands place. Okay, so x equals, thousands is 3 zeros, but that 6 makes me want to round that 4 up, so negative 1.404. Okay. Okay, sorry. So again, look at the side. Can you type it in the calculator? Yes. So there's no reason to change the form of this one. Log base 4, 1 over 64 is negative 3. So x equals negative 3. Here, we have a negative base, which is not possible. So I want to show you, if you type this in your calculator, math alpha math, negative 7 base 49, it tells you non-real answer. Well, we haven't dealt with those, so we're not going to put not possible. Here, these match, so x equals 9. This could also be a calculator problem. Math alpha math, 3 to the math alpha math, log base 3, 9 equals 9. Sorry if you can't see. Here, anytime you have 1 as an argument, the exponent is 0, so x equals 0. If you were to change this form, it ends up being b to the x equals 1. Anything to the 0 power equals 1. That is one of your rules that we've learned. Okay, here, these have equal signs. They're not all equal to x or simpler like these. They have more than one log. Okay, here, everything has a log. Therefore, the logs can cancel. So we don't have any numbers in front of the log, so I'm going to cancel. Okay, minus means divide. So x divide 8 equals 6. How do you get rid of divided by 8? Well, the opposite is multiply by 8. So we're going to multiply both sides by 8. That cancels, and we get x equals 48. Because 6 times 8 is 48. Here, they all have a log on both sides of the equal sign, which is good. We're going to get rid of the 2, make it the power first. So we get, we're going to cancel the logs now that we got rid of that. And we get 5x minus 3. Subtract means divide. 3 squared is 9 equals 3. Okay, so then we have to solve this for x. So we're going to multiply both sides by 9. We have to get rid of that division first. And I get 5x minus 3 equals 27. Add 3, add 3. That gives us 5x equals 30. Divide by 5, divide by 5. X equals 6. Now remember, you can technically do these in the calculator. So I'm going to show you really fast. Not on all of them, but I'm going to show you algebraically, but you can do this. So you'll go to y equals, you'll type the left side in y1, the right side in y2, just the way you see it. So math alpha math, log base 4, 5x minus 3, minus 2, math alpha math, log base 4 of 3. And then the other side of the equal sign is log base 4 of 3. Math alpha math, log base 4 of 3. So then you'll come to your table, and you're looking for where the ugly decimals match. And if you look at 6.79248, 0.79248, there they match at 6. Now this only works when it's a pretty answer, okay? Technically you could hit graph. See the line there, and the line here. We know they touch, so you could do second trace. We wanted to calculate our intersection. Press enter, enter. Oh, you have to see how it doesn't have a number. So you'll just have to find the line. Scroll close to your thing. Press enter, enter, enter. So it tells me 6 at 0.79248.125, blah, blah, blah. Okay? Either way. But again, I'm showing you algebraically. So here, there's nothing in front of any of the logs, so we can just cancel. So x equals 4, plus means times, so 4 times 3, divide 2. Well, you can do that in your calculator. 4 times 3 divide 2 is 6, so x equals 6. Now, this one also, they all have log. Cancel, cancel, cancel. I get x divide x minus 1 equals 3. Okay, so we have to get rid of the x minus 1 on the bottom, so we're going to multiply both sides by x minus 1. This cancels that. I get x equals 3x minus 3. I subtract 3x from both sides, and I get negative 2x equals negative 3. Divide by negative 2, divide by negative 2. X equals, it ends up 2 negatives cancel, and I get 3 over 2. Now this is one you wouldn't find in the calculator in the table, but you could do it in the graph, like I showed you. Second trace 5 for intersect. Now 29 and 30 are different. If you notice, they don't all have logs, so all the logs don't cancel. Okay, so this is plus. We need to get rid of the 1/2 first. 36 to the 1/2 power. Remember, that's just the square root of 36, which is 6. Okay, so this ends up being just 6. So we get times, so x times 6 log base 3 of 6x equals 7. I could not cancel the log because the 7 did not have a log. But I can change the form. I can't type that in the calculator now. It's just like 19 through 24. I can't change the form, so I can't solve, put it in my calculator, so I'm going to change the form. 3 to the 7th equals 6x. Well, 3 to the 7th power equals 2,187. Divide both sides by 6, so divide by 6, and I get math enter, enter, because remember we want fractions if we can. X equals 729 over 2. Now, this number 30, there's not one on the test like this that counts. There is a bonus question like this, a little worse, but like this. So I want you to kind of think about this one differently. So this is log base 2. This whole thing is my argument of this log. Okay, so therefore I cannot type that in the calculator because there's an x. So I can change the form. 2 to the negative 2 power equals the argument. Okay, well, 2 to the negative 2 power is 1/4. So I get this equals 1/4. So again, I can do that same thing. This whole, I'm going to change colors as I, flip through this. This whole thing is the argument. So I'm going to change the form again. 16 to the 1/4 power equals the argument. Okay, 16 to the 1/4 power is 2. So I get log 1/2, base 1/2 x equals 2. So last time, because I only have one log left, I'm going to change the form. 1/2 to the 2nd power equals x. So alpha y equals enter, 1/2. I should probably put this in parentheses. Squared is 1/4. So x equals 1/4. Okay, 31 says, which of the following are undefined, not possible, and why? So this one is possible because they're both positive. This is not possible. So you can even type this in the calculator. Math, alpha math, log base 4 of 20 is totally possible. It gives you an answer. Here, math, alpha math, log base 1 of 5 is not possible. Okay, you cannot have a base of 1. Okay, here is not possible. Base can't be negative. here is not possible. Oh, sorry. Argument can't be negative. So all three of those are not possible. All right, halfway done. 32, you had one like this on your quiz. Okay, it says David solved the equation log base 2 of x equals 1 on his graphing calculator. Remember, that means you plug this in y1, this in y2. So there's the answer to my first question. Log base 2 of x, and then you plugged y2 as 1. It says, what is the solution to the equation based on the graph above? Well, here's the 1, and here's the log base 2 of x. So they touch right here, which is at x equals 2. Okay. 34. Write the domain of the following functions. Remember, a domain is the opposite of your inside change, comma, infinity. So this is positive 4, so it'll be negative 4, comma, infinity. This has no inside change, so 0 to infinity. This has no inside change, so 0 to infinity. This has no inside change, so 0 to infinity. Okay, and you can even put these in your calculator and double check. So like the first one, math alpha math log base 2 of x plus 4. If I hit graph, you see how it's scooted all the way over here to the negative 4? So that's correct. Like try this last one. 4 times math or log base 2 of x. It goes all the way to the x. Okay, so these are right. 35. Graph the function f of x equals log base 3 of x is shown solid graph. So this is that one. Log base 3 of x. Okay, along with the transformation of the function, the dash graph. Write the equation that has been transformed. So if you look at any point, here's a pretty point, it went up 2. Here's a pretty point-ish, it went up 2. So we know that it went up 2. So transformation up is outside change. So it's going to be y equals log base 3 of x plus 2, or you don't need those and you get y equals log base 3 of x plus 2. That's not inside, therefore it is correct. Okay. A, draw a table for log base 2 of x. Draw a table of the inverse. So, guys, calculator. Log base 2 of x, second graph. Okay, so the table for the, okay, is 1, 0, 2, 1, 1, 0, 2, 1, and 4, 2. I'm only going to put those 3 points. Okay, now it says draw a table of the inverse. So, guys, remember, inverse is just opposite, where x and y flip. So, this is my inverse. 0, 1, 2. I took y and put it in the x place, and x and put it in the y place. Okay. So, what is the inverse of log base 2 of x? Well, remember, it's exponential, and there's no inside or outside change, so it's just 2 to the x power. Sorry, I should have written this in the front, but I didn't. That's the fancy way of writing inverse. Almost done. Okay, 37. If points 15, 2 is on the graph of the function log base b of x, which point on the graph of the function would be on the that equation plus 3? So if this shifted up 3, well, up is your y changing, because that's your range that changes. So if my y changed by 3 plus 3, what's 2 plus 3? It'd be 15, 5. because remember, f of x means y, so we just added 3 to the y. If the point 4, 3 is on the graph of a function, what is the point of the graph on this function? So this has an inside change. The x is changing. Remember, that means it's going to go right 1 and up 6. Well, right 1 would be 5. Remember, because it's opposite. So it'll be 4 plus 1 is 5. And then a plus 6 to the y would be 9. Okay, and 39 through 41. Find the inverse of the following and state the domain and range of the inverses. Okay, so here the inverse would be log, because that's the inverse of exponential. The base is 4. Remember, the bases stay the same. And this has a plus 7 on the outside. So the opposite of an outside plus would be an inside minus. So x minus 7. Okay. Remember, your domain is the opposite of the inside, so it's positive 7, infinity. And your range is always all real numbers. Okay, here, again, the opposite of exponential is log. My base is 2. Now, this has an outside minus, which will turn into an inside plus. And this has an inside plus. It's going to turn into an outside minus. Now remember, domain is just the opposite of the inside, so negative 3 to infinity. And range is always all real numbers. Last one, okay? Log is the opposite of exponential. Okay, base is 8. Now this has an outside plus, so it's going to turn into an inside minus. Remember, your x always goes inside. Okay, and then this has an inside minus, which is going to turn into an outside plus. Okay, range is the opposite of the inside, 4 to infinity, and, or domain, sorry, and range is always all real numbers. All right, guys, test Friday, study, try your best. That's all I can ask.